All right, this is a short video created for the Physics 2 class summer of 2020, and it deals with scientific notation. Now, this is a supplementary assignment. You're not required to do this assignment, but you are required to know scientific notation. It's considered prerequisite knowledge, knowledge that you should have coming into the class. And my experience is that many students don't know scientific notation. So watch this, it'll be brief, and you'll know everything you need to know about scientific notation. Scientific notation is a way to convert very large or very small numbers to a shortened length. So example, the speed of light is 300 million meters per second. In scientific notation, it's 3 times 10 to the 8th meters per second. Those two numbers are equivalent. Note, by the way, express units of measure as you see above, not with a slash such as m/s. M/s is fine if it's a final answer, but even so, go ahead and write them one directly over the other, because you can actually cancel and multiply units of measure, and oftentimes you need to do that to figure out a problem. So go ahead and write them directly, one directly over the other. Even take 2 lines of paper to do that, because it's important that they be shown in that format. Okay, the parts of the scientific notation are: the coefficient is the large number in front, the base is always 10, and the smaller number, the power, is called the exponent. So the first task is convert the following to scientific notation. So here is what you do. The technique is identify where the decimal is. And you may say, I don't see a decimal. So you put it here at the end. It actually is at the end. It's implied there, but you don't write it. And you move it over until you need to create a number between 1 and 10. Okay? So number between 1 and 10. Actually, technically, between 1 and 9.99. It can't be 10. So what we're going to do, where do we place that decimal? And the comma, by the way, is not important. I'll talk about that in a second. So you're going to move it to right here. 1, 2, 3, 4 places. So that you have 4.5, 6, 7 times 10. And then you need an exponent. The exponent is simply how many places did you move it? How many loop-de-loops did you do? 1, 2, 3, 4. So it's 10 to the 4th. The final question you have to ask is it a positive 4 or a negative 4? If the number you started with is bigger than 1, in this case 45,670, then it's a positive number. If it's less than 1, not a negative number, but less than 1, it would be a negative 4. We'll talk about that in a second. So this is how you would write this number in scientific notation. Okay, the next number is one that's famous in chemistry, called Avogadro's number. And it actually is this big long number. So how would you write that in scientific notation? If you want to try that for yourself, go ahead and pause. And I'll return in just 2 seconds. Okay, so we return. Again, ignore the commas. So I'm going to have to move this 1, 2, 3, 4. And I counted 23 loop-de-loops I had to do. So to make the number, again, we're trying to make the number between 1 and 10. So that would be 6.022 times 10. And then I had to do 23 of those, so it's 10 to the 23rd. Okay, again, you want this coefficient to be a number between 1 and 10. So you have to move the decimal to the appropriate place to make it a number between 1 and 10. All right, what I was just mentioning is commas are used to make a number more readable. They don't mean anything in the U.S. In some countries, though, they're treated as decimals and are important. But in the U.S., they're just meant to make a long number a little more readable. Okay, let's go ahead and try a couple with what are called, we would think of as decimal numbers, all right? So where would you move the decimal to make this number between 1 and 10? You'd have to move it right here between the 4 and the 3. So you had 4.31. That's a number between 1 and 10. So let's do that. So I had to move that 6 places over. And since this is a very small number between 0 and 1, it's less than 1, that's going to be a negative exponent. So it's to the negative 6th. Okay, keep in mind, that doesn't make it a negative number. If it were a negative number, you'd have a negative sign out in front right here. It makes it a positive number, but it's between 0 and 1. That's what this is telling you. Okay, try the next one on your own. I'll pause the video if you need to. All right. So the decimal is here. It would have to be here to make this a number between 1 and 10. That's 3 positions over. That will give me 9.022, 9.002 rather. That's a number between 1 and 10. And I had to move it 3 places. And since it is a number that's less than 1 originally, then we put a negative sign there. Okay, so that's how you make those conversions. Generally, if you're given a problem in scientific notation, you can give the answer in scientific notation. You do not have to convert it to a decimal number like one of these or one of these. You don't have to convert it to a regular number. But you should know how to do that, because sometimes the answers on a multiple choice test might give you the numbers in scientific notation, and then you're given the answers on the multiple choice in regular numbers. You have to know how to convert. Okay, so we're going to now convert the following to decimal numbers. Okay, the way you do that is you take the coefficient and write it down here by itself. Okay, the next thing you do is you look at the exponent. You're going to have to move it 4 places. So the question is which way, to the right or to the left? So you just, rather than trying to memorize that, just use common sense. 10 to the 4th is equal to 10,000. It's a big number. To make this number get towards 10,000, I'm going to need to move the decimal to the right. Okay? So we're going to move it to the right 4 places. Okay, and I call this the egg carton, so you got to put the eggs in, and those eggs are zeros. And don't leave the answer like that. That means the decimal's now here, so that's actually 49,700. You don't necessarily have to write the decimal point at the end. That gets into a concept of significant figures, and we don't deal with that in this class. At least I don't know if we do, but from what I've seen of the coursework so far, we don't. Okay, there you go. How about one with a negative? Okay, so again, we write the coefficient. And this tells us it's going to be a small number less than 1. So which way would I have to move this decimal to make it a number less than 1? I'd have to move it to the left, 3 positions. Okay, fill in the eggs. And your final answer is, and good formatting of numbers suggests that you should actually put a leading 0 in front of a decimal number like that. It doesn't change the value of the number, but it's always done. If you didn't do it, it doesn't make the answer wrong, but it's just the way you're supposed to format it. This 0 doesn't mean anything. Okay, so try to do the others on your own. You can pause the video if you like. I'm going to go ahead and just do them silently. Okay, don't make the mistake of thinking that this means how many zeros are in front here. Remember, this one really doesn't mean anything. It means you move it 6 positions over, but you'll end up with 5 zeros after the decimal point. So, just again, you're just counting how many spaces over you have to move. All right. So multiply the following scientific notation's number by multiplying the coefficients and adding the exponents. And then you adjust the decimal to be a number between 1 and 10, as we said before. Leave the answer in scientific notation. Okay, so what you're going to do is this. You're going to multiply these coefficients. That's a times sign. And you're going to add the exponents. So that's how you multiply 2 scientific notation numbers. So 2 times 4 is 8. It's always going to be times 10. You're leaving it in scientific notation. And 2 plus 5 is 7. So that's the answer for that. Okay? I'll do the next 2 silently. Be very careful with negative signs. It's easy to get them backwards or confused. For the coefficients like this, of course, you can use a calculator to do that. All right, so first of all, we have to multiply these 2. So negative 6.8 times negative 4.3 gives you a positive. A negative times a negative is a positive. It's positive 29.24. And then it's always going to be times 10. Now what you have to do is you have to say negative 2 plus negative 5. I'll write that down below. Okay, and that's going to equal negative 7. So you may even want to do that on a calculator. Be sure you don't go in the wrong direction with that. Okay. All right. So this is going to be -7. All right. So there's our answer, but it's not entirely finished. The coefficient should be a number between 1 and 10. So you just use the following reasoning. To get this to be a number between 1 and 10, you need to move this over to there so that you have 2.924 times 10. Now, if you do that, you don't want to change the value of the number. So if you do that, since you made this number smaller, it went from 29.24 down to 2.94, you have to make the exponent bigger. And be careful, which way is bigger? Is it -6 or -8? It's going in the positive direction is making it bigger, so it's going to be to the -6. So let me say that again. I had to move the decimal over one place. I made the coefficient smaller by going from 29.24 to 2.924. I made this smaller, so I have to make the exponent bigger by 1. What you did is you divided this by 10, this number by 10 to get this. So by doing this, you're actually multiplying by 10. So the value of these two numbers is exactly the same. All right, I'm going to do the next one silently, and you do it on pause if you'd like to do that. Okay, so I did the multiplication. I ended up with 18.5. I added the exponents. -9 plus 2 is -7. Now I have to turn 18.5 into a number between 1 and 10. I left my 5 off here. Let me correct that. And that would be 1.85 times 10 to the -6. You made this number smaller, so you got to make this number bigger. The reason it's important for you to learn to do this for practical reasons is on a test, if you had done this calculation and done it correctly, this number would not show up as the answer. This one would. So you have to be sure you know how to make that conversion. All right, now we're going to do some division. And with division, the rule is just the opposite. You divide the top by the bottom. Trying to make a division sign there. Divide the top by the bottom, and you subtract here. And be careful if these are negatives, because that can get tricky. Okay, so the first one is 8 divided by 2 equals 4 times, and it's 5 minus 2 is 3. So 4 times 10 to the third. All right, and if you need to use a calculator for this, you use a calculator for anything you want in this class. There's no restrictions on that. Okay, so let's go ahead and I'll do the next two silently, and you can stop and try to do them on your own. Okay, let's look at what we did. When you divided these two, you got a big long number on your calculator. How many decimal places should you go to? I just say 2 is a good number. We're not dealing with the concept of significant figures in here. But go ahead and just put 2 places after the decimal. That's always safe to do. So I had to round this from 29 up to 30. And the exponent is 5 minus -2. Again, I would write down these until you get really good with them, because I find students make a lot of mistakes when the exponents are negative signs. So 5 minus -2, the negative becomes a positive, so 5 plus 2 is 7. Down here, this number divided by this gives you 0.54. -3 minus -8 equals -3 plus 8, which is 5. Okay, now this number 0.54 is not a number between 1 and 10. What we have to do is slide the decimal over to here, make it 5.4. So since I made this number bigger, I have to compensate by making the exponent 1 digit smaller. You move as many digits up here as you do places over to get the number to be between 1 and 10. If I'd had to move 2 places over, then it would have been a difference of 2 here. All right. Okay, finally we're going to add scientific notation numbers, and the same rules would apply to subtraction. So adding numbers in scientific notation is rarely done, but when doing so, both the base and the exponent must be the same. So here we have a base and exponent 10 to the ninth, 10 to the ninth. So you can add these two numbers because they're the same. And that would give you, change that, that's 8. 5 plus 3.7 is 8.7 times 10 to the ninth. Okay, if they're not the same, the base and the exponent, you have to make them the same by adjusting the decimal here. So we can either make this number 10 to the fourth or make this number 10 to the third. I'm going to go in this direction, make this one 10 to the third. So what I have to do is if I want to reduce this by 1, I have to compensate by making this number bigger. If I'm going to make this smaller, I have to make this number bigger. So I'm going to have to move that decimal place over here so that I have 37 rather, once I change the decimal. 37 times 10 to the third. So again, I made this bigger, so I made this smaller. This is multiplying by 10. This is dividing by 10. So that's the same value number. All right? And I'll go ahead and keep it wrapped in parentheses here. Okay, there we go. You have base and exponent the same. So 5 plus 37 equals 42 times 10 to the third. All right, now that I have that, I have to adjust the decimal. It's 42. The decimal would be right here if you saw it behind the 2. So I move that over and make it 4.2. And since I made this number smaller, going from 42 to 4.2, I have to make this exponent bigger. Okay, and there is the final answer. Okay, that wraps up just a little lesson on scientific notation. I will always have these kind of supplemental lessons if I feel that there might be a concept that might be challenging for you or some of you might not know. And they'll be in the Google Classroom, and I'll set up the Google Classroom so it looks exactly like the Edgenuity lessons, same kind of organization, so you'll know where to find things. All right, we'll talk about that at a later time. All right, so have a good day, and good luck in the class.